Hello everyone, today we will discuss to find the maximum number in a given string 16 bytes long and store it in location 0510. Okay, in this problem we have a 16 byte long string. Start with address 0500 0501050 2050 0504 0505 0506 0507 0508 0509 0508 050B 050C 050D 050E 050F. This is your 16 byte long string. Okay, this is your 16 byte long string. In a string, store the data like 01, 02, 03, 04, 05, 06, 07, 08, 09, 11, 12, 13, 14, 3, 4, 5. These are the data written in this memory location. Our aim to find out the maximum number and store in this location. Okay, to start with our code. Okay, first instruction is move si, 0500H. Okay, mean of this instruction is you initialize your source index with this address. Okay, next instruction is move cx, 0010. Okay, what is the mean of cx, 00? You initialize your counter register cx with 17 number. Okay, 17 means in hexadecimal you write 16 like F, and this indicates 16, 10 indicate 70. Okay, next instruction is move AH, 00H. Here we move the 00 number in our AH register. Next instruction is CMP, compare AH, SI. What is the mean of AH comma SI. Basically compare instruction. We subtract AH value with SI content. Okay, if AH value is higher, our carry flag register status is not high. If AH value is lower, then our carry flag status is high. Next instruction is JAE. JAE means jump above or equal. Means if the content of AH is above or equal, then jump to the marked label. Otherwise, move to the next instruction. Okay, the marked label is XX, and next instruction is MOV move AH comma SI. Here, suppose content of SI is higher and AH content is lower, then in this case we store the content of SI in our AH register. Next instruction is INC SI. Okay, INC SI means we increase the source index address by 1. Next instruction is loop NE. Loop NE means it's decrease the counter value by 1. Suppose here write 0 0 1 0 and is decreased by it decrease the counter value by 1, like 17 to 16. Next, and it's check the condition. If counter value is not 0, to continuing the process, searching process. Okay, and mark to the and move to the mark label. Label is YY. This is your label YY, and next instruction is move SI comma AH. Means the highest value stored in our AH register move to the source index. At last instruction is HLT. What is the mean of HLT? HLT is terminate our program. To start with the first number, when we execute a move SI comma 005 AH, our source index address change with this address is 0500. Okay, next instruction is, this is your SI. Next instruction is move CX comma 00H. Means your CX, this is your CX register. In this we have a CH and CL. This is your lower bit data. Lower bit data is stored in our CL register. It move to the CL register and CH value is 00. Next instruction is move AH comma 00H. Means your general purpose register AX. Here we have AH and AL. Your AH register data replaced by 00 value. Okay, next instruction is CMP AH comma SI. Okay, the content of AH is 0 0 and SI content is 0 1. So AH minus content of SI. AH is 0 0 and SI is 0 1. When AH content subtracted with SI means 0 subtracted with 1, our carry flag status is high. Then jump above or equal means if AH value is above or equal, then jump is occur. But in this case our carry flag is high, means AH content is lower than SI. Then we move to the next instruction. This instruction we move SI content to our AH register. SI content is 1 and AH content is 0. 1 and 0. The content of SI move to our AH register. So here the value of AH register is 1. Next instruction is INC SI. In present time, source index indicate 0500 H address, but after the execution of this instruction, your source index address is updated with 05001 H. Okay. Next instruction is loop any. Suppose in this case loop any is decrease the counter value by 1. Suppose here the counter value is CX value is 0 1 0 is decrease the counter value by 1. Next value of counter is F. Okay, and check the condition loop while not equal to. Okay, if CX value is not equal to 0, okay, then your loop will be exist. Okay, and move to the mark label. Here our CX value is not 0, then loop any, move to the pointer to the mark label. YY is your mark label, your pointer is move this label. And next instruction, content of SI is check the 0501 location is 2 and content of AH is 1. Okay, then in the compare instruction AH minus 2, again carry flag is high, jump above an unequal condition is not satisfied, means our AH content is lower than SI. Then we move the content of SI in our AH register. In this instruction, after the execution of this step, the content of AH is replaced by 2. Okay, again increase the source index address and check the condition. After at the last and in the AH register we get the highest value, and at the last you get the highest number in your SI source index. Source index is 0510. Okay, same program will execute in our software. So erase this and double click on EMU 8086 and click on new, select empty workspace, make it OK and write down first move SI comma 0500 H, press enter key, Next instruction is cx move cx comma 0010 h, press enter key. Next instruction is move ah comma 00 h, press enter key. Next instruction is cmp ah comma bracket si, press enter key. Next instruction is JAE and mark label is XX, press enter key. Next instruction is move AH comma use large bracket SI bracket close, press enter key. And next instruction is INC SI, press enter key. Next instruction is loop any and mark label is YY, press enter key. Next instruction is move SI, move in large bracket write down SI AH comma AH, press enter key. Next instruction is HLT halt, mark label in front of compare instruction, mark label is YY, and in front of INC instruction mark XX label. Okay, and click on emulate. Okay, and next step is this is your emulator. Click on view, select memory and update update your offset address. Offset address is 0500. Click on update and write down number 01, 02, 01, random write and number 04, 05, 06, 04, 05, 11, 04, 05, 08, 04, 03, 02 and click on update. Okay, click on update and this is your AX register BX, this is your CX TX, and this is your source index register. Okay, this is your emulator, this is your original code. We opened the flag register, this is your flag register status. Okay, when we execute a first line move SI comma 0500H, your source index address is in present time 000. After the execution of this instruction, your source index address is updated with this address. Okay, so click on single step. Your source index address is updated with 0500, and next instruction is move CX comma 0010H. After the execution of this instruction, your CX register CL is updated with 0H. This is your CX register used as a counter. This is a CL and this is your CH. So in this case 10 is lower bit data is stored in your CX register. In CL register it 00 updated with 10. Okay, execute this step. Okay, after the execution of this step, your CL register data is updated with 10. Okay, next instruction is move AH comma 00H. Mean of this line is the 00 value move to our AH register. Okay, this is your AH register. In present time AH value is by default 0, but when we execute this line, 00 is replaced by 00. Okay, click on single step. Okay, AH value is 00. Next instruction is CMP AH comma bracket SI, means content of SI. Content of SI is 01, because SI indicates 0500 address, so content of SI is 01. 01 is compared with AH. Okay, when AH minus SI, your carry flag status is high. When our carry flag status is high, then jump above an equal condition is not satisfied, then move to the next line. Okay, check. Okay, this our carry flag status is high, then jump above an equal condition is not satisfied, then we move to the next instruction. Next instruction is move AH comma SI. After the execution of this line, the content of SI move to the AH. In present time content of AH is 00 and SI content is 01. 01 move to our AH register. Check this. Okay, our content of AH is increased by 01. Okay, next instruction is INCSI. INCSI is increase our source index address by 1. In present time our source index address is 050500, but when we execute this instruction INCSI, our source index address is updated by 1. Next address is 0501. Okay, next address is 0501. Okay, next instruction is loop any. Loop any means first loop any. In this instruction it decrease the counter value by 1. Okay, this is your counter value, it's decreased by 1, means in present time we have a 10, is decreased by 1, next value is F. Okay, and check the condition. If counter value is not 0, then pointer move to the marked label. Okay, see, in this case our counter value is not 0, then pointer move to the marked label, it's moved to the YY label. Okay, in this case the yellow line is moved to YY label and CX value is 0F. Okay, check the value 0F and pointer move to this label. Okay, in this instruction SI content move to AH. SI content is in present time SI move to indicate 0501 address. The content of 0501 is 2 is stored in our SI, and content of AH is 1. When 1 minus 2, our again in this case AH our carry flag status is high, then jump above an equal condition is not satisfied, then we move AH content to SI. Check. Okay, carry flag again high, jump above an equal condition is not satisfied, then we move SI content to our AH register. The content of SI is 2 and in present time we store in our AH register is 01, so 2 SI content 2 replace 1. Okay, check this, 1 replaced by 2. Next again increase the source index. Your source index indicates 0501. Click this single step, your SI address is updated by 0502. And next instruction is loop any. Its decrease counter value by 1. then counter value is after the execution of this line, your counter value is 0 E, and it check the condition. If your counter value is not 0, then it's moved to the mark label. Mark label is YY. Okay, mark label is YY, and counter value decreased by 1. Again, content of SI compare with AH. Content of SI is 1 and content of AH is 2. When execute this instruction, then our carry flag is 0, means jump above and equal condition is satisfied. Okay, means you move to the mark label. Mark label is INC SI. You script move AH comma SI instruction. Okay, zero flag carry flag is 0. You move to the mark label, means above condition is satisfied. Okay, you move to the INC SI, and again you move to the next line, loop any. It's decrease the counter value once, and this process happened, and at last you get a your source index, you get a highest number. Okay, click on run and get the highest number in 05010 memory location. Run. Okay, 30 is the highest number you get in this memory location.